In this video, we'll find the protons, neutrons, electrons, and mass number for chlorine. So chlorine has two predominant isotopes that we'll look at. We'll talk more about isotopes later. What we'll do first is figure out the information that's the same for all isotopes of chlorine. So on the periodic table, we see the atomic number. That's 17. So the atomic number for chlorine is always going to be 17. Doesn't matter what isotope we have. The atomic number, that's equal to the number of protons. So we also know we'll have 17 protons. On the periodic table, we have Cl for chlorine, Cl. This is considered a neutral compound. If it had a minus after it, that would be an ion. It has a charge. But as it's written, this is considered a neutral compound, and all the elements on the periodic table, they're considered to be neutral. So in neutral elements, protons are going to be equal to the number of electrons. So for both isotopes, we have 17 electrons. So when we talk about isotopes, the atomic number, protons, and electrons, they're going to be the same. What's going to be different is the number of neutrons, and since protons plus neutrons give us mass number, the mass number, that'll be different as well. So often when you have a table like this, you'll be given either neutrons or protons, and then you can figure the other one out. If not, then we usually round this to the nearest whole number. So let's round this to 35. So if we have a mass number of 35, that means 17 protons plus some number of neutrons will give us the mass number. So 18 plus 17, that gives us 35. So we have 18 neutrons for this isotope of chlorine. We call it chlorine-35, chlorine-35. So that's the first isotope. For chlorine-35, about 76% of chlorine atoms, if you had a big sample of chlorine, about 76% of those atoms would be a mass number of 35 with 18 neutrons. We also have some chlorine-37. So if it's 37, that means 17 plus something gives us 37. 17 plus 20, that'll give us 37. We'll call this chlorine-37. There is a chlorine-36, but there's only a trace of that, just a little bit. This chlorine-37 makes up about 24% of the atoms in a sample of chlorine. So we have these two numbers. The average atomic mass on the periodic table, we get that by averaging these two numbers based on how much there are of each one. So there's more of this 35 here than there is of the 37, so we kind of have this average in between. But we could write a notation to show the individual isotopes, and that's called nuclear notation. So for chlorine-35, we would put 35 up here, that's the mass number, and then the atomic number we'd put down here. So this is chlorine-35. For chlorine-37, we would put the mass number, and the atomic number is the same because it's chlorine. All chlorine has an atomic number of 17 protons. So this is nuclear notation for isotopes. And then on the periodic table, this notation, it tells us the number of protons, and then it tells us the average of the different isotopes of chlorine. And the only thing different with isotopes will be the number of neutrons, and then, of course, the mass number, because that's protons plus neutrons. You can't really tell the number of isotopes just by looking at the periodic table. You can get an idea that, for instance, most of them are going to be 35, but you really can't tell the number of them. You need to do that experimentally. This is Dr. B with the number of protons, neutrons, electrons, and mass number for chlorine. Thanks for watching.